Hey guys, today we're going to talk about factoring quadratics using, that's right, my approach. As I said in class, I came up with this approach when I was in 7th, 8th grade. There's a ton of formulas and things to memorize for this, for factoring, that I decided to put it all into one method so that if you follow this method, no matter how complicated or how less complicated the problem was, it's always solvable. So let's get into what is Lopez approach or the Lopez method. And if you hit like and share and subscribe, maybe I will start trending and actually get this method, recognized by many other people. Let's get going. So here we have a standard form of a quadratic, right? Here in the beginning we have ax squared bx plus c. Our goal is to find the factors of this quadratic. What two things multiply to give you this entire function? Okay? Usually when we're finding factors of numbers, we're looking for just two things that multiply to give you that. So like 64, you have 8 times 8. 100, you have 10 times 10, or 20 times 5, or 25 times 4, right? There's a lot of different factor combinations for numbers that you get. Well, for quadratics, you can also find two things that multiply to give you this function. Now, why would we want to find two things that multiply? Because these factors of a quadratic actually produce the x-intercepts. When you find the factors, it allows you to figure out when does it cross the x-axis. And we'll get to this in another video. But for now, let's just focus on how do you find the factors. Later, we'll focus on how to use the factors to find the x-intercepts or the solutions. So here's what I do. I start by making a table with 3 columns. One for every part of this equation. One for the x squared, one for the plus 15x, and one for the 36. Then, underneath each column, I create I create or I list the factors in that order. So for x squared, the factors of x squared, what two things multiplied to give you x squared? Well, that's going to be x times x. I skip over to the last column and I do a similar thing. What two things multiply to give you 36? Well, there's actually quite a bit. There's more than just one possibility. So I'm going to write my list of possibilities on the right-hand side and then figure out what works. Okay? So I have 6 times 6. I have 2 times 18. I have 4 times 9. We have 3 times 12. 36 times 1. And I believe that's it. At least whole numbers, right? Now, out of all of these factors, the more you do this method, the better you're going to get into figuring out what works and what doesn't work. Okay? How do I choose what works? Let's just start with the first one and go from there. Okay? I'm going to start with this 6 times 6. And I'm going to write the factors of 36 right below. That's 6 times 6. Now, what I'm going to do is I'm going to cross multiply 6 times x and fill in that spot here in the middle. So when I do 6 times x, I get 6x. And in the bottom, I do 6 times x, and I fill in this space as also 6x. The reason why I changed the color here is because I want you to see how this lines up, right? The column here in the middle, the purpose of this column here in the middle is to check our work. And here's how we do it, right? We want to figure out, does this add up to 15x? This column has to add up to the number here on the top. It's always going to be addition. So we cross multiply to fill in this table, and then we want to figure out, does this add up to positive 15x? And 6x plus 6x is 12x. So no, that does not work out. So I know that 6x or 6 times 6 is not going to be the factors that I'm interested in for this problem. And then I can continue going down this list to figure out which one is which, okay? Now, I'm going to skip to the correct answer because I already know what the answer is to save us some work. And I'm going to put 3 times 12. When I cross multiply, 12 times x, sorry, let me change the color again. I want the outside to be the same color. 3 times 12. When I cross multiply, I get 12 times x, and I put 12x. And in the bottom, 3 times x, I get 3x. Let me change the color again. I'm sorry. So I get 12x and 3x. The reason why I changed the colors is so that you see what column goes with what. Notice how these add up to 15x this time around. 12x plus 3x gives you 15x, and I found myself my solution. Whichever combination actually adds up to this column in the middle is the one that's going to be correct. Everything else, goodbye. Now you might have to try a few of them for now and experiment, but by the end of this video I will show you a shortcut to be able to expedite this process and go a lot faster. This column in the middle is purely to check our work. We just want to know, does this add up to 15x? Once we know that it does, my solution will be the factors that we found, the numbers on the outside. This is why I left it in blue. So my answer will always be horizontally, and I pair these numbers side by side. So f of x equals x and positive 3, or x plus 3, and x and positive 12, or x plus 12. I always look at my answers horizontally. Okay? This is what we call factored form. Versus standard form and vertex form that we discussed in the previous video. Okay? So, what are we saying here is that if you multiply x plus 3 times x plus 12, you're going to get x squared plus 15x plus 36. You can always graph this on Desmos, this in Desmos, and see that they match up and they're the exact same equation. Let's try a few more examples to figure out and get a hang and groove of this, okay? In this scenario, we have x squared plus 17x minus 60. I break it down into my 3 columns. And then on the left, I have my factors of x squared. To get x squared, I'm going to multiply x times x. For now, I'm going to keep this very simple. This is why a equals 1, because the 1 value here is just 1x times 1x. In our next video, we'll talk about what happens when you have a number different, like 2x squared, or 4x squared, or 6x squared. For now, we're going to keep this very basic. A equals 1, so we're just going to have x times x. The third column, we need to find the factors of negative 60. Now, because we're dealing with a negative number, when you multiply 2 factors, one of them has to be a negative number. So as an example, to get to 60, you can multiply 6 times 10. But to get negative 60, you need to make one of them a negative. So it could be 6 times negative 10 or negative 6 times 10. One of those combinations gives you negative 60. So now I got to go through all my possibilities. Okay, I have 6 times 10. I have 20 times negative 3. Or negative 20 times 3. We have more, right? 5 times 12. Or 5 times negative 12. Negative 5 times 12. 60 times 1, or 60 times negative 1, and negative 60 times 1. What else? Am I missing something? Oh, you also have 30 times 2. And negative 30 times 2. If there's more, I apologize, but you basically list all of your factors. Now, this is how we can speed up this process a little bit. I want my answer in the end to be positive 17, right? So if you ignore the fact that you have negatives and positives, I want to look at these factors and add them or subtract them to see if I can get any of these combinations to give you a 17. For example, 6 plus 10 is 16. And if I subtract them, right, like 10 minus 6, I get 4. 16 and 4 is not 17, so I'm not even going to experiment with this one and try it out at all. Let's try the next one. 20 plus 3 is 23, and 20 minus 3 is 17. Ooh, this might work. Right? I'm looking for 17, and that might work. Let's look at the next scenario. 5 plus 12 is also 17, and 5 minus 12 is 7. This might also work as a combination. 60 plus 1 is 61. 60 minus 1 is 59. This will definitely not give me 17. And then lastly, 30 plus 2 is 32, or 30 minus 2 is 28. This also does not work. So now instead of trying out 10 possibilities, I'm going to just try out 4 possibilities. Okay? And I put them on this column and I experiment. Let's find out if it works. So I have 20 times negative 3. Okay? I'm going to cross multiply. I get negative 3 times x gives you negative 3x. And 20 times x gives you 20x. And notice how negative 3 plus x gives you 17x. It does work. So we got lucky. We got it right in the first try. Okay? Now that we found our answer, eliminate the middle. The middle is just to check our work. And our solutions are, as always, horizontally. Here and here. So f of x equals x positive 20, or x plus 20, and x minus 3, or x negative 3. That's my solution. Now, if I go through the other ones, you're going to notice that these are not going to work with each other. They're not going to be correct solutions. But feel free to try them all out, and you'll see that the only one that actually adds up to 17 is the one that we tried, the 20 times negative 3. All right, let's try one last one. In this last one, what I strongly recommend is you pausing the video and give it a try. Try to see if you can solve this one on your own. And then you can press play and solve it with me. So I make my 3 columns. And the first one I have x times x. On the last one, to get 48, I have a lot of possibilities. Okay, we have, let's see, 24 times 2. I have 48 times 1. We have 6 times 8. We have 4 times 12. What else? 24 times 2, 48 times 1, 6 times 8. 16 times 3. Now, one thing that I do want to bring up, and I'll show you here in this first scenario, right? I'm looking at adding these or subtracting them to get a 16. 24 plus 2 is 26, and 24 minus 2 is 22. That's not going to give me the 16 that I'm looking for. So I scratch that one off. 48 plus 1 is 49, and 48 minus 1 is 47. Also not a 16. 6 plus 8 is 14, and 6 minus 8 is 2. Also not going to work. 4 plus 12 is 16, and 4 minus 12 is 8. There's our 16 that we're looking for. And then lastly, 16 plus 3 is 19, and 16 minus 3 is 13. Not going to work. So I have 4 times 12. When I cross multiply, I get 12x and 4x. Let me change the colors here, I forgot. x and 4x. Notice how this does not add up to a negative 16. It adds up to a positive 16. Will you ever be able to add two positive numbers and get a negative one? The answer is no. So what needs to change is I need to make both of these negative. If you recall, negative times a negative turns into a positive. So if I make both of them negative, it still multiplies to give you positive 48. Negative 4 times negative 12 is positive 48. And when you add them, negative 12 plus negative 4 gives you negative 16. And now it works. Now it adds up to the negative 16 that we want. So I ignore the middle, that's just to check my work. And my solutions are always horizontally. X negative 4. X minus 12. And there it is, guys. You got it. To sum up everything, this is what you're really... You have your function, your general function, ax squared plus bx plus c. This is your general function. You're going to break it into 3 columns, and the first step, find the factors of a. So here we have x times x. Second step, find the factors of c. So we have a number times another number. Then you want to cross multiply. So cross multiply and check, does it add up to b? So when you cross multiply, you want to make sure that it adds up to b. And then fourth, your answer will always be horizontally. So we ignore the middle column and we write x and x. If it's positive, we do x plus the number. If it's negative, we put the minus the number, and that goes for both routes. So if I were to throw a rhyme or spit a rhyme here, I would say find the factors of a, find the factors of c, cross multiply and add up to b. You know you have it if it was meant to be, and then finally write your answers horizontally. Alright guys, I will see y'all later, and as always, out calculator.